Area under the curve. Now, we've already looked at area under the curve involving integration. So let's have a go at this example. So it says, find the area under the curve y equals x squared minus 6x between x equals 1 and x equals 3. So here's a sketch of that graph. Y equals x squared minus 6x. So we're asked to find the area between the values 1 and 3. So we're looking at this section here, coloured in blue. So remember, to do this we're going to use integration, and then we're going to sub in the value of 3 and the value of 1. So we're going to integrate between 3 and 1, x squared minus 6x dx, which is equal to x cubed over 3 minus 6x squared over 2. And we're doing this between 3 and 1. So, mustn't forget my plus c. So let's sub in the values then. So, just remember here that 6 divided by 2 is 3. So this part here we could simply write as 3x squared. So x cubed over 3 minus 3x squared, and we're putting in 3 and 1. There we go, just tied it up a little bit. So 3 cubed over 3 minus 3 times 3 squared, well 3 squared is 9 plus c, and we're taking away from that 1 cubed over 3 minus 3 times 1 squared, so 3 times 1 plus c. So tidy up each part here. So that's going to become 27 over 3. 27 over 3 is going to be 9, because 3 cubed is 27, divided by 3 is 9. 3 times 9 is 27 plus c, minus 1 cubed over 3, which is a third, minus 3 times 1 is minus 3 plus c. So if we finish this off, we're going to end up with the following. So you're going to have minus 18 plus c minus, well, 3 is the same as 9 over 3. So it's a third minus 9 over 3. A third minus 9 over 3 is 8 over 3 plus c. Sorry, minus 8 over 3. And yet again, if we sort this out now, the two c's, because we've got a plus c minus a c, they're going to cancel each other out. So we've got minus 18 minus minus 8 over 3. So we've got minus 18 plus minus 18 plus 8 over 3, which becomes minus 46 over 3. Now you'll notice that I put a question here. Well, there's something wrong here. It says, why is this a negative area? Because you can't have a negative area, that doesn't make sense. And the reason you get a negative value is every question we've done so far, if we look at our diagram, we've always had a graph that has been something like this, and we've been asked to find the area under the curve. Now when we're finding the area under the curve, we're finding the area between the curve and the x-axis. So we're finding the bit underneath it. Now with the one that we're doing here, well, you're still finding the area between the curve and the x-axis, but this time, rather than it being below the curve, we're looking above the curve. That's why we end up with a negative value, because we're looking at the area above the curve. So the area, in actual fact, is not minus 46 over 3. The area is actually, is 46 over 3, rather than being minus 46 over 3. Now, that affects the question when we start to look at a question like this one, where it says sketch the curve with the equation y equals x in brackets x plus 2 in brackets x minus 3, and find the area of the finite region bound by the curve and the x-axis. So if we just draw a sketch as it says in this question, now what we should know is if we set this equal to 0, we can find the following x solutions where the curve crosses the x-axis. Well, it's going to cross at 0. What value makes x plus 2 equals 0? That's minus 2. And the value that makes x minus 3 equals 0 is 3. So our curve is going to look something like this. We're going to have a x and a y-axis. It's going to cross at 0, minus 2 and 3. And if you're to expand this, like we're going to in a minute, you're going to find that you're going to have an x cubed graph. It's going to be a positive x cubed graph, so it's going to go something along these lines, the sketch of this curve. And what we're asked to find is we're asked to find the finite region bound by the curve and the x-axis. And what that means is it means this region here, which is enclosed between the curve and the x-axis. Now, the problem is, remember what we did a minute ago on the first example? Well, if we were to find out the area of this region here, because we're actually looking a bit above the curve, we're going to end up with a negative area. Whereas this bit here will be a positive area. So we can't just integrate here between 3 and minus 2. Because what's going to happen is, some of this negative area here is going to counteract some of the positive area here. So what we have to do is we're going to have to do integration twice. Once between 3 and 0, and make the answer positive, like we did in the first example, and look at the area between 0 and minus 2. So we're going to be integrating, well, we only have to integrate it once, but we've got to substitute in two pairs of values. We're going to have to substitute in 0 and minus 2, and 3 and 0, and add our two final solutions together. Now, before we can integrate, we're going to have to expand our y equals x, x plus 2, x minus 3. So, if we just concentrate on the double bracket part first, we're going to have y equals x. It's going to be x squared plus 2x and then a minus 3x. That's going to be minus x. And 2 times minus 3 is minus 6. So finally, x cubed minus x squared minus 6x. So now we're ready to integrate. So let's integrate x cubed minus x squared minus 6x dx between 3 and 0, and we're also going to do it between 0 and minus 2, but let's do it one at a time first. So between 3 and 0, so it's x to the power of 4 over 4 minus x to the power of 3 over 3 minus, it's going to be x squared, so it's going to be 6 divided by a new power 2, which can be 3. Okay, and plus our constant. And that's going to be between 3 and 0. Now we're expecting this part to be a negative area because it's this part here where we're actually looking above the curve. Now, don't forget in core 2 you can use a calculator, so the fraction bit will be really quick to sort out on your calculator. But remember to leave your answer in the form of a fraction. Don't go changing it into a decimal. So, subbing in the values. So, 3 to the power of 4 over 4 minus 3 to the power of 3 over 3 minus 3 times 3 squared plus c. Now in the second part, for the 0, this part will be 0, this part will be 0, and this part will be 0, because in every one you times in by 0. So all you're left with is the plus c, so it's going to be minus c. So we just need to tidy this up. So 3 to the power of 4 is 81 over 4. 3 cubed over 3 is 9, because 27 divided by 3 is 9, and 3 squared is 9 times 3 is minus 27, and the c's cancel each other out. So that finally simplifies to, and that baby, figure it out, and a calculator comes out as minus 63 over 4. So remember, that's the area above the curve, so that basically means that the bit between 3 and 0 is an area of 63 over 4. Now, we've done half the job because we've done the area here. Now we need to do this area here, between 0 and minus 2. So it's exactly the same as what we've done before in the first part, but now instead of doing between 3 and 0, we're going to do between 0 and minus 2. You must always put whatever the higher value is as the top one and the lower one as the bottom value. So we're going to integrate between 0 and minus 2, and our equation is x cubed minus x squared minus dx minus 6x, sorry, and same integration as before, so let's give it x to the power 4 over 4 minus x cubed over 3 minus 3x squared plus c between 0 and minus 2. So if we substitute 0 in, everything apart from the c will become 0 because we're multiplying by 0 again. So the second part is going to be minus, so it's minus 2 to the power 4 over 4 minus 2 cubed over 3 and minus 3 times minus 2 squared plus c. So let's sort this out. So minus 2 to the power of 4 is going to be 16 over 4, which is 4. Minus 2 to the power of 3, or minus 2 to the power of 3 is minus 8, so it's minus 8 over 3. Minus 2 squared is 4. 4 times 3 is 12, so it's minus 12 plus c. And if you sort this part out, the c's yet again will cancel out, and we've got 4 minus 12, so we're going to have, let's just sort out a bit in the brackets. I'm now assuming that we've cancelled the c's out. So 4 minus 12 is minus 8, and we've got minus 8, which is going to be plus 8 over 3. If we sort that part out, we're going to have the following: minus 16 over 3, which becomes a plus. Minus becomes plus, so it's 16 over 3. So now we've got both sections for our area. We've got the 16 over 3, and we've got the first one we found, which was 63 over 4. So we're going to add those together. So finally, we're going to have the 63 over 4, and we're going to add on our 16 over 3. And it's purely calculator work now, and you'll get the final answer 253 over 12. So there is some equations when you're looking at negative areas, the area above the curve, that you're going to have to do the integration in two parts.